Good morning, everyone. Welcome to Common Hour. My name is Rick Moog. I'm chair of the Common Hour Committee and professor of chemistry. I want to welcome everybody to this week's Common Hour. Next week's Common Hour will be held right here and will feature Dr. Amanda Kemp speaking on, she's a racial justice and mindfulness mentor. She'll be talking about sort of a follow-up to our Day of Dialogue next week. Before we begin today's event, I'd like for us to thank this week's pizza servers, the Quantitative and Science Center. The Quantitative and Science Center, or Q&SC, is the hub of science and quantitative tutoring at F&M. Located in Martin Library, Q&SC offers tutoring for selected biology, chemistry, physics, astronomy, computer science, BOSS, econ, psychology, and statistics classes. As is the case at all of our common hours, there will be a question and answer period at the last part of the presentation. So please plan to stay until the end of the Q&A session. Common Hour will end promptly at 12:30. The Q&A session is open to members of the Franklin and Marshall community. Today, we'll be, as always, we'll be taking questions from students first. If you have a question, please come and line up by these two microphones so that our speaker has a sense of just how many questions there are to address. When you come forward to the microphone, please state your name, year, and or college affiliation. And after students are finished, we'll welcome questions from anyone. And now I'd like to introduce my colleague, Pablo Hennig, who's Associate Professor of Biology.
Okay, good afternoon. Welcome, everyone. I'd like to first extend a special welcome to a large group of students from McCaskey, which is the local Lancaster high school. So I'd like to start by thanking the sponsors of this Common Hour, the Faculty Center, the Andrew D. Mellon Foundation, the Department of Psychology, the Program in Women, Gender, and Sexuality Studies, and the Department of Sociology. So it's my honor to introduce the speaker of today's Common Hour, Dr. Nilanjana Dasgupta, better known as Buju by everyone. Buju's talk today, part of it is about inoculating women's self-confidence and motivation against negative stereotypes. She certainly got inoculated herself as a kid. She grew up in a family full of strong female role models. Buju grew up in Calcutta, India. There, her maternal great-grandmother was a feminist writer. Her maternal grandmother worked with Gandhi helping with refugees during partition, and then spent all her life championing women's causes. Her mother was a professor of physiology at Calcutta University, and her paternal grandmother ran the extended household with an iron hand. Buju came to the US to go to Smith College, a women's college, from which she graduated with a major in psychology and a minor in neuroscience, summa cum laude, and highest honors. From there, she went to Yale University for her PhD to work with one of the leading figures in the field of implicit bias, Mazarin Banaji. It was at Yale where I got to meet her, not because she was a brilliant student or because she got herself arrested demanding a union for grad students, but because I was dating her sister. So I've known Buju for the last 20 years, mostly as my sister-in-law, and I can tell you firsthand that she works incredibly hard and is amazingly organized. And it's also fun and scary at the same time to have arguments with her, because she has zero patience for bullshit and will tear into your arguments with lots of pleasure. After graduating from Yale, she spent 2 years as a postdoc in the lab of Tony Greenwald at the University of Washington in Seattle, another great place to study unconscious bias. Then she took her first faculty position at the New School for Social Research in New York City. Afterwards, she moved to UMass Amherst, where she has been since 2003. She's now professor of psychology, the director of the Faculty Equity and Inclusion, and the director of the Institute of Diversity Sciences. Over the course of the years, she has done an enormous amount of research on the field of implicit bias and how it informs problems in the real world, such as employment discrimination, educational disparities in sciences, engineering, and technology, and the underrepresentation of women and ethnic minorities in professional leadership roles. On the way, she has published a large body of work and garnered numerous awards. I won't bore you with the list. I mean, her CV is 24 pages long. I'll just mention that she's been funded by grants from the National Science Foundation and the National Institutes of Health, including a prestigious NSF Career Award, and that she has received the highest prizes that the University of Massachusetts confers, the Chancellor's Award for Outstanding Accomplishment in Research and Creative Activity, and the Distinguished Academic Outreach Award in Research. So without further ado, I'll leave you with Dr. Dasgupta.
I didn't know all the stuff that you would say. Thank you. Okay, so, I can hear the mic. I have to say, it's amazing that a college has a weekly program every Thursday where the whole community comes together. I wish we had something like this at UMass, or that I had something like this at Smith. So this is unusual and should be treasured. I want to, this idea for my coming here started with Pablo Hennig, who you now know as my brother-in-law, and my sister, Sri Dasgupta, and they were the first people who initially suggested this idea of applying to Common Hour. I should also say that the planning of this was really, and the conceptualization was done with Stephanie McNulty, who I haven't seen yet, who has been amazing. Oh, there she is at the back. And I want to also thank the Common Hour committee and the staff, the event planning staff, who were amazing. It's not common that I get a piece like this when I speak, so this is great. I'm really curious about your questions, so I'm going to try and go quickly, but I hope really to hear your comments and questions at the very end. So I want you to imagine two students, student A and student B. In middle school, both these kids did equally well in math and science. They're equally engaged in class, and they were totally into the subjects. They go to high school. They're still performing equally well, getting equal grades in math and science, but now student A seems less interested and seems more tentative in class and somewhat less confident. And student B is the same as they were before. They graduate from high school, same GPA, and go to college. Student A majors in communication, student B in engineering. Two students, same ability, but diverging tracks. If you guessed that student A is likely to be female and student B is likely to be male, you would be right many of the times. And this is the story of many students in the US and in countries in Western Europe and North and South America. And I want to show you a graph that illustrates this. So these are national data on students' performance on standardized tests in science across many different countries. And what you can see is that on your left, boys and girls are doing equally well in standardized tests in science. But a few years later, when they go to college and university, the graph on your right, now young women are substantially less likely to major in science-intensive fields. No difference 4 years earlier, and then you see a big difference in college and university. You find the same pattern of data in math. So in middle and high school, girls and boys perform equally well on standardized tests across many countries. Again, this seems to be particularly true in North and South America and Western Europe. The data look a bit different in Asia. But then when these students go to college and university, you see this big disparity. These disparities in STEM education end up meaning that there's a scarcity of women who are employed as scientists, engineers, technology creators, computer scientists, which are some of the fastest growing jobs in the global economy, and also some of the best paying jobs. So in other words, the gender difference in STEM education ends up being one contributor to income disparity between women and men, even among those who have college degrees. So the question that I'm interested in is what causes these gender disparities? It's true that some degree of discrimination or glass ceilings are important contributors to this, but that's not the whole story. There have been a bunch of people who've written recently, both academics and journalists alike, who argue that sometimes girls and women who are talented and well qualified to pursue science, technology, engineering, and math, STEM. By the way, that's what STEM stands for those of you who don't know. Some students opt out freely, allegedly, because they are just not that interested. This was a position taken by an article published in the Boston Globe that caught my attention several years ago, where the journalist was trying to explain this big disparity in gender disparity in STEM, and cited social science research and said, I quote, "When it comes to certain math and science-related jobs, substantial numbers of women, highly qualified for the work, stay out of those careers because they would rather do something else," unquote. In other words, the argument was women can freely choose to say no to careers in science and engineering and tech, and if they freely choose that, then what's the problem? The problem is that the assumption underlying this interpretation and the data on which it was based is as if individuals' freedom to choose, individuals' choice of one discipline over another, one career over another, as if it's a free choice determined solely by one's talent and motivation, unconstrained by societal forces. The question that I'm interested in is asking, are these choices really free? Might individuals' freedom be constrained by subtle cues, subtle factors in learning environments, in work environments, that signals who belongs here, who is likely to make it, who's going to be the leader or the star, and who may not make it. So I propose in my research that individuals tend to gravitate towards fields where they feel they belong, where they feel they fit in, oftentimes because those fields fit with positive stereotypes about their own group. And on the other hand, people tend to, over time, move away from other fields and careers where they feel like misfits, where they feel like odd ducks, because those fields often fit with negative stereotypes about their own group. And interestingly, this might happen independent of the person's actual ability. So if this is true, what factors might release these constraints and increase individuals' real freedom to pursue any academic or professional path that they wish, unconstrained by stereotypes? And this is where my research is situated. So to try and address this question, I developed with my graduate students and postdocs a model that I call the stereotype inoculation model. So briefly, just using a biomedical metaphor, the idea is just as biomedical vaccines protect and inoculate our physical body against noxious bacteria, so too exposure to admired experts and admired peers from one's own identity group protects and inoculates one's mind against noxious stereotypes, hence social vaccines. So in other words, exposure, seeing those admired exemplars from one's own group succeed and excel in science, tech, or engineering, and one's peers act as social vaccines for women in STEM. So that's sort of the metaphor, and now I'm going to sort of show you a visual illustration of what we hypothesize. So first we predict that a big factor that determines students' experiences in STEM has to do with the demographic environment in which they learn those subjects, whether it's high school, middle school, college, graduate school, and so on. By demographic composition, I mean who are the experts they see, who are the peers they see. The more students see experts and peers from their own group in a learning environment, the more likely they are to develop a sense of confidence, motivation, worry less about how they're doing, the more likely they are to develop positive attitudes towards that field, feel a sense of identification, this is important to me, and more likely, further downstream, they're likely to speak up in class, be actively engaged, put in more effort, do better, take the next step, the next advanced class in that field, and think about pursuing careers in that field. So that's sort of prediction hypothesis number one, if you will. Second, we predict that the impact of seeing these experts is particularly likely to matter for students who are both a numeric minority in a field or in that classroom, and who are aware that there are societal negative stereotypes that are casting doubt on their ability. So for those students, seeing someone who's further along, who's very successful, is particularly powerful, because seeing that person undercuts the power of the negative stereotype and makes it and boosts their confidence. Third, we predict that seeing those own group experts is particularly powerful when those students, those individuals, feel a sense of connection with that expert. That sense of connection, or what I often call identification, makes the path from one's present self as a beginner, as a novice, to a future self as a scientist or an engineer or an entrepreneur seem far more plausible, because one can follow the storyline and imagine going from here to there. So in my research, I test kinds of questions, or the different pieces of this model, using particularly girls and women in STEM as a case in point. But I will say that although the research I'll show you is about women in STEM, I also have some data on middle school and high school, but because of the short time, I took those slides out, but they're at the back of my talk if I need to get back to that. And I also should say that the same ideas apply to students of color, to first-generation students in STEM, and also in elite colleges. But my examples will focus more on gender. So what I want to show you is the different ways we've tested this model, and I'll show you some numbers. I'm a quantitative researcher, and ultimately numbers, stories are good, but for me, numbers either say that I'm onto something or not. So the first way I wanted to test this hypothesis, this is research done with my graduate students, Jane Stout, Matthew Hunsinger, and Melissa McManus. We wanted to test whether having female faculty teach intro-level, gateway courses might act as a social vaccine for women students in their classes, and whether it would have a different impact on women compared to their male peers. So I made friends with my colleagues in math and stats over at UMass, and with their help, amazing help, conducted a study in calculus. So this is a large class broken up into small sections, and it so happens some of these sections were taught by women faculty, some by men faculty, and we recruited students, both men and women, from from all these sections. The beauty of this class from an experimental standpoint is all sections had the same syllabus, they all had the same exam, grading was done in a de-identified way, so the faculty didn't know whose exams they were grading. And we followed students from the beginning to the end of the academic year, beginning to end of that course, and faculty and the students in that class were not aware of our hypotheses. We described it as generally as something on student learning in math and calculus in particular, but we said nothing more. So we measured a bunch of things. Today I'm going to focus on just a few of the variables that we measured. We measured students' attitudes towards math compared to a humanities subject like English. And we measured it in two ways. One, by using standard survey instruments, which in our jargon we call explicit attitudes, so the attitudes you can report, where we ask students, how much do you like math? How much do you like English? How interesting is it? How boring is it? Those kinds of questions. We also measured their attitudes in another way, which we call implicit measures, where the idea is where we don't ask people to report their attitudes, but we infer their attitudes by their task performance. So the basic gist of this implicit attitude task is that people sit at a laptop and flashing on the computer screen words at a time are words that have to do with math, so theorem, computation, calculus, and words that have to do with English. Novel, Shakespeare, syntax, grammar. They have to categorize these words as quickly as they can using these two pre-designated keys. In between these words, flash other words, words that are generically good or bad. So words like happy, joy, or sad, cold, and they have to categorize those words as quickly as they can using the same two keys. In one part of the task, math and good are paired to the same response key, English and bad to the other response key. In the other part of the task, it's switched. Now math is with bad, English is with good. And the order in which they do the task is all balanced out. The idea is, if in my mind I love math, then that association, that positive association, should help me perform very fast on the version of the task where math goes with good. Because how I feel is consistent with what the task is asking me to do. I should respond really quickly, make very few mistakes. On the other hand, if I'm math phobic, if I have worries and anxieties about math, even if I don't choose to speak about them, that negative association should actually interfere with my task performance on the math good version. Because in my head, math makes me think I'm worried, but the task is forcing me to say good stuff. So people end up going slower, making more mistakes. So this difference in the speed of response between the math good version of the task and math bad version of the task is one way in which we measure implicit attitudes. We also measured students' identification with math. How important is it to themselves? Again, using a standard survey measure and using this rapid implicit association test, or IAT, where we are measuring the speed with which they associate now math with I, me, myself, or math with not me. But the same idea. We measure their confidence. We asked them to predict how they would do in the class, and with their permission, we went to the registrar's office and got their grades in calculus. So let me show you what we found. So the big picture is that who the faculty were that was teaching calculus had a profound effect on women, but not men. So this is what the graph looks like. I'll walk you through, let me orient you. The black bars are the women students. The gray bars are the male students. Here are the bars representing students in sections taught by women. Here are bars representing students taught by men. On the vertical axis, higher numbers mean stronger liking, implicit liking. I like math, but implicitly, not what they're necessarily saying. What you can see is that for women students, if their professor, calculus professor, is a woman, they have strong, favorable attitudes towards mathematics, but not so if they're taught the same material in sections taught by the male professors. For male students, it doesn't make a difference. The gender of the professor doesn't make a difference. I should say, what students are saying is, I really like math. After all, most of these students want to major in STEM. But that's not what they're showing on the implicit task. We also measured their, I should say, the first one I misspoke, is identification with math, how much they associate math with me. This is the attitude task, how much they like or dislike math. It's the same idea, the graph looks a little bit different. Here, negative numbers means that they strongly, implicitly dislike math and far prefer English. Numbers around the 0 point means that they like both subjects equally. Again, the black bars are female students, the gray bars are male students. For women in sections taught by female professors teaching calculus, they like math and English equally. For women in sections taught by male professors, they strongly prefer humanities over math. For male students, the gray bars, the gender of the professor doesn't make a difference. They like both subjects about equally. We then asked students to predict how they would do in the class, which is sort of a proxy for confidence. And what we find, again, is the same pattern. Women expect to get a better grade if that professor is a woman than a man. For male students, it doesn't make a difference. This, I want to remind you, is despite the fact that the students knew that the grading was done in a de-identified way, that their faculty instructor had no idea whose exams they were grading. Nevertheless, these women students' expectation of how well they would do was bumping around, moving around as a function of who the professor was. So compare this graph on confidence with how the students actually did. If you look at how they actually did, the women students outperformed men in all 15 sections of calculus. In every of the sections, women did better in calculus than did men, on average. It wasn't true of all students. But the takeaway is that these students knew their calculus. That was not the issue. What was far more fragile was their confidence. That was sort of one of my main points. It's not ability, it's confidence. And confidence comes from whether you feel you belong. So we know that in some fields, the number of women professors is few. So it's not always possible to have introductory courses taught by female faculty. So what do you do then? We wanted to test in a follow-up study if media exposure to women scientists and engineers have the same effect as actual contact with professors. So this time, we went to our College of Engineering and recruited a bunch of students from engineering. And this time, all the students were women. We brought them over to my lab in psychology and randomly assigned them, this is like a randomized controlled experiment, randomly assigned them into one of three groups. Either we showed them pictures and biographies of female engineers, people who are faculty at various institutions, people who are engineers in industry, people who are in government, all kinds of different types of engineering, and diverse group of people demographically. So we showed one group multiple pictures and biographies like this about how they got interested in engineering. In the case of Dr. Anna Howard, she's an electrical engineer, what interested her, how she worked on NASA's Mars rover. It talked about all of that. So that's one group of students see that. Many people like this. In another group, we show them male engineers, again, of different types of engineers, different races and ethnicities. What you can't see from the back, but trust me, the description is identical. All we do is swap the pictures and change the names, but the content of the description is the same. Or in the control condition, that our third group, we tell them what engineers do, but we make no mention of gender. Then we measure their implicit attitudes towards engineering. And this is what we find. The black bars are those who were randomly assigned to read about female engineers. The gray bars are women who were randomly assigned to read about male engineers. The white bar are the control group who saw nothing about gender. On the vertical axis, on the y-axis, higher numbers means more favorable attitudes towards engineering. What you can see is that for women who happen to see for an hour-long experiment, multiple exemplars of women engineers showed more favorable attitudes towards engineering than other women who were randomly assigned to read about same content, male engineers or engineering innovations, our control group. We wanted to dig deeper into this group, and we wanted to see, did reading about these people affect how much students identified with them, how much they felt connected to them? And did that predict their own confidence and career goals? And what we found is that the more these students identified, felt connected to the women they read about, the more confident they felt about their own ability, which in turn statistically predicted their intentions to pursue engineering careers post-college. So just as a sort of resting point, here's that inoculation model again, and I've shown you some data for every box that's in green. I've shown you some data showing that either real-world interaction with or media exposure to experts from one's own gender group has positive effects on women's confidence in STEM, their favorable attitudes and identification with STEM, their career goals, and that whole pathway happens particularly for women who are in fields where they're underrepresented, and it happens especially if the students feel a sense of connection or identification with with the people they're reading about or they're encountering. I haven't said anything about how peers might function as social vaccines. So let me turn to that. When students transition from one life stage to another, for example, from high school, those of you in high school will soon appreciate this, from high school to college, in that transition point, there's a lot of worries about fitting in, there's a lot of worries about am I good enough, there's a lot of worries about finding your place in that new environment in which you're landing. In that period, in that self-doubt, we think that peer may be particularly effective social vaccines in that transition points, especially for students who are numerically underrepresented in their chosen field and who are aware of larger societal stereotypes about their group. The question we didn't know, which is where I was interested in, is does the gender of that peer mentor matter? Does it matter if students in that first year of college, as they're going from high school to college, have a peer mentor who's a man or a woman, or just having a mentor, peer mentor is good enough? That's the question we set out to answer. So this time, we conducted a longitudinal field experiment that I want to tell you about. This experiment is actually continuing because all the students haven't graduated from UMass yet. But I want to show you a slice of the data. So this is a study where we recruited first-year incoming students who intended to major in engineering in the summer between senior year in high school and entry into UMass during new students orientation. We randomly assigned them again into one of three buckets. We either assigned them to a peer mentor who was a woman, who was a senior in their intended major, or a male student, engineer, who was also in their same major, or in the control condition, which I call the business as usual condition, they didn't have any mentor. The mentors were students who were sort of student leaders who were in their junior and senior year who had volunteered to be mentors. And my graduate student and I had trained them pretty extensively on how to be mentors, but we had given them lots of freedom to do a variety of things with their mentees depending on what they thought that the mentee wanted or needed. The only restriction we gave them was that mentor-mentee pairs had to meet once a month and one-on-one. For anything social, have lunch together, have a study group together, whatever, but they had to meet once a month for a year, after which the mentors graduated from college and the mentoring relationship ended. But we tracked the mentees' progress from the moment they walked into campus, before the mentors were assigned, through that first year in college, past the mentoring relationship had ended, into their sophomore year, until graduation. I'm going to show you data from the first 2 years, so when they were first years and sophomores. First, let me say that all the mentors were incredibly dedicated and good. So when we asked the mentees, how much support do you get from your mentors? How available is your mentor to you? How much chemistry do you feel with the person? How much do you admire them? On all those questions, they gave very high ratings to all mentors, and there was no gender difference in ratings of male mentors and female mentors. The only place where there was a difference is how close they felt to the mentor, and a little bit towards how similar they felt to the mentor. So my main point here is that the mentors were really dedicated and doing a really good job. But the impact of those mentors on students' own sense of confidence, on their own career aspirations, was actually quite dramatically different. So let me show you students' feelings of belonging in engineering as a function of who their mentor was across that first year in college. So the black line here are students who were randomly given a female mentor. The gray dashed line are students given a male mentor. The dotted line are students who had no mentors. On the vertical axis, 0 is the starting point. Numbers above 0 means that their feelings of belonging are going up, getting more positive. Negative numbers means that their feelings of belonging are rapidly dropping in engineering. As you can see, for women with female mentors, their sense of their place in engineering holds steady, doesn't change across that first year in college. For those with male mentors and no mentors, even though they liked and connected with the male mentors a lot, their sense of belonging for themselves drops sharply across that academic year. We looked at confidence, roughly the same pattern of data. Women students who had female mentors, their sense of confidence in their ability holds steady. Whatever they came in with in the beginning of the academic year in September held steady in May of the next year. Those who had no mentors, their confidence dropped sharply. Those who had male mentors were sort of in between, in the middle of the pack. We measured their anxiety about their engineering classes relative to how motivated they felt. So this is a ratio where higher numbers means more anxiety about engineering. Again, you see women with female mentors, the black line, their anxiety held steady. Whatever they felt at the beginning, they felt at the end. Women with no mentors, their anxiety shoots up pretty sharply across that first year in college, as does, but in the middle of the pack, those with male mentors. How much do you want to pursue an advanced degree in engineering, a master's or a PhD after graduation? Same pattern. Women with female mentors are still on it. Women with male mentors and no mentors, their interest in pursuing advanced degrees in engineering drops sharply. At the end of that first year, with their permission, we got their grades from the registrar's office. 100% of students who had female peer mentors were still in engineering at the beginning of their sophomore year. 82% of those with male mentors were still there at the end of the beginning of the sophomore year, and 89 in the control condition. No difference here. That's a sort of statistical error. The differences between the women mentors and the other two groups. Okay, 1 year goes by. The mentors have graduated, the mentoring relationship has ended. We are still tracking these mentees. Let me tell you, this is a laborious effort. The data remain remarkably the same. If anything, it becomes even more accentuated. Women who had female mentors in their first year, by the end of their sophomore year, they're still holding steady in terms of how much they feel that they fit in engineering. Those with male mentors, somewhat unexpectedly, who originally had male mentors, now plummet pretty sharply in terms they don't feel like they belong in engineering. The control condition is hanging out in the middle. For anxiety, everybody's anxiety goes up in their sophomore year. That's not a surprise. If you're in engineering or a field to it, that's allied to it, you know that these are, everybody goes up. I feel my mic coming in and out. But the main point here is that those with female mentors, their anxiety goes up the least. Those who originally had male mentors, now those mentors are gone, their anxiety goes up the most. The control condition is in the middle. And intentions to pursue advanced degrees, ditto. Those women with female mentors are still intending to pursue an advanced degree. The slope of this line is flat. Those who originally had male mentors or no mentors, they really are now beginning to exit out of engineering more. So the main takeaway, so we are still following these students, by the way, because we want to see what happens at graduation. All of them haven't yet graduated. The number of women in engineering is so small, it's about 15%. It takes many years, it's taken 5 years to get 120 women into the study, and so not all of them have graduated. I think this is our last cohort. So the main takeaway from this study is that peers who are just a couple of years senior than the mentees still have the social vaccine impact. I want to give you one more example about how peers function as social vaccines, and that has to do with teamwork. Lots of fields in STEM, it's not very common unless you're a theoretical physicist or a mathematician. Most work is done in teams, in collaborative teams. The question is, who is on your team? And does it matter if there are other women on the team and how many women? So there's some research showing that having other women on the team and having a critical mass is beneficial, but it was never clear what percent of that critical mass is enough. Is it 50%? Is it 75%? So again, we did the study on teamwork, again in engineering, where we recruited students from the College of Engineering, brought them into our study in my lab on a teamwork study, where they were told that they would be given a couple of engineering problems, and they had to solve it as a team, and the best and the most creative solutions, the team would get a cash prize. So students came in, they met with their teammates, we jerry-rigged or engineered, pardon my pun, I just thought of that, into one of three kinds of teams. Either teams where women were in the majority, 3 women, 1 man, or gender parity teams, 50-50, or a female minority team with 1 woman with 3 other guys. What the students didn't know, but what you should know, is that in every team, there was only 1 person whose behavior we were interested in, and she was always a woman. The other 3 people in the team were our research assistants. They were engineering students. We had recruited them, paid them, trained them to act in exactly the same way. So what they were saying and doing was entirely scripted. We were always the same. We were only interested in how the gender composition of the team would affect that 1 person, and there were multiple teams. Okay. We measured, after they got to know each other, we took them into separate cubicles, measured students' anxiety about the upcoming task. We measured how motivated and eager they were. We threw them into the team and measured how much they spoke up. Did they lean in, to use Sheryl Sandberg's language, or did they lean back and were they quiet? After the task was over, we measured their confidence in their ability, and we measured their career aspirations. So here's what we found. So this is going to be the gender composition of the team influencing anxiety about the task that is about to begin and or motivation. So higher numbers means more anxiety. The lightest bar are women in female minority teams. They are the only woman with 3 other men. The darker bars are the 50-50 teams. The black bar are the female majority teams. What you can see is that the women who were a solo, they felt substantially more worries and anxieties about their ability than women in the other 2 teams. We wondered if this was really happening because those first-year students who had just come into college and now they were their first years, if they were the group that was really anxious. So we disaggregated the same graph that I showed you into first year versus everybody else, sophomores, juniors, seniors. In this graph, the black bars are those first year students. The gray bars are the more advanced students. What you can see is that if a woman was the only woman on a team and she was a first year student, that's the group that was most anxious and worried. That anxiety dropped if she was in 50-50 teams and a little bit more if she was a majority in the team. For senior students, it didn't make a difference. Now, I don't know if it didn't make a difference because they had become inoculated by that time and figured out how to navigate the system, or because if they had switched out of engineering into another field. We don't know, we can't differentiate those 2 options. We looked at how much these women spoke up. Again, we found that the women who were in the female majority team jumped in, helped solve the problems, were totally engaged in the problem-solving task, were much more so than the women in the other 2 teams. Interestingly, all these women were onto the problem. They were on the right track in solving the problem. We know that because we had them start the task alone. So it's not that they didn't know how to approach the problem, it's that they didn't speak up until they were in this team. Okay, so I've thrown a lot of data at you, and I'm really interested in your questions. So I'm going to take everything I said and translate into recommendations. So for a college like F&M, or for any organization, for a university like mine, for any businesses, any place, high schools that are interested in gender diversity, and again, I'm saying gender diversity, but in your mind, please hear also racial ethnic diversity and inclusion, as well as for first-gen students. But I'll try and stick closer to my data and talk about gender based on these data. So here is what I think we can do to sort of get more of our students who are interested initially, keep them in the pipeline and have them flourish. One, in our gateway courses, it's very important for students to come into contact with female STEM faculty. It doesn't have to be just gateway courses, it could be through advising or other ways, but for young women coming into college, to see scientists and engineers and computer scientists who are women makes a big difference. Sometimes they themselves don't know how much of a big difference it makes, but we can tell from these data. Second, fund peer mentoring programs. Again, especially in that transition year. Once students find their place, they have a study group, they figure out where they fit, they don't need it quite so much. But in that space, or in that sort of liminal, uncertain space, they need that mentoring. And it's particularly important in our data if for underrepresented students to have a mentor from their own group. I didn't say anything specifically about our data, but we asked our mentors to talk about their own early struggles. What made it difficult? How did they make it? What were their sort of silent worries? And one of the things that I think made a big difference is that having these mentors who are senior graduating students who are doing really well in engineering articulate how they felt as first years, I think normalized the experiences of these incoming first year students. For faculty, for my male colleagues in this room, for my male colleagues at UMass and other places I give this talk, it's really important to showcase the success of the research of technical women through examples that you give in class, through guest speakers that you have, through other colloquia and brown bag, because absent saying anything, the assumption is that the discoveries that are happening, the innovations that are happening, the assumption of many students, because of the stereotype, is that the innovator is a man, the scientist is a man. So I think there's something affirmative that needs to be done, and faculty can do it very easily. And a bunch of faculty I know have already started doing this in various fields. I know of colleagues in biology at a small liberal arts college. I know my colleagues at UMass do this a lot, but it requires some thought. The other one, which I didn't say anything about because of time, in my research in middle school and high school, we found that when teachers, faculty at college or high school teachers and middle school teachers teach science by linking the basic concepts to its social relevance, why does it make a difference in the world? What problems can you solve? That connection between basic science and its real-world impact is what gets kids hooked into STEM. And there's some survey research showing that that is especially true for students of color, for first-generation students, and for women, who are much more likely to gravitate towards fields where they can make a difference, which are people-oriented. And science and engineering is, but it often isn't something that we talk about in that way. Emphasize collaborative learning. Again, in this K-12 that I'm doing right now, we found that for girls especially, collaborative teams work really well instead of just lecture-style classes. And so what I'm testing now in a biochemistry class, thanks to a colleague of mine who is my biochemist, who is my collaborator, is to see whether collaborative learning has the same impact on college biochem classes. So collaborative learning, I think, is another best practice. For classes that involve team projects, pay attention to the demographic composition of the team. Avoid teams with one of a kind. So one of my colleagues said to me, I always thought that I should make the teams heterogeneous. That's true in some ways, but if there's one student of color or one woman in a team with everybody else who is alike, they feel out of place. So I think it's more important for the success of underrepresented students to cluster them. Timing matters. In all the research I've done, the sweet spot is to insert these interventions at periods of transition. From the transition, again, from high school to college, transition from college, you're graduating seniors to the workforce, that's another transition, or to graduate school. Transition from middle to high school is another important transition, but timing matters for these interventions. So what I'm going to do is say what I sometimes say at the beginning, but I want to emphasize it and say it now. Usually, we talk as individuals, but this research is not an individual endeavor. It only happened because of my graduate students and postdocs who are collaborators and often first authors on this work, my colleagues in mathematics and engineering who opened doors and allowed us to come in and because they were interested in their experiences of their students, to funding from the National Science Foundation that's funded my research for the last 20 years, without which none of these very laborious studies would have been possible, and to an amazing large posse of undergraduate research assistants from psychology, from brain sciences, from engineering, from mathematics, who were our research assistants, who coded the data, who collected the data, who pretended to be actors in those teams, without whom this would not be possible. And thank you. So I think I would love your questions, and we have 10 minutes. I spoke very fast.
I'd like to invite any students who have questions to please come forward.
Don't be shy. I would love to hear your experiences at F&M. I would love to hear your experiences in college, both from students and from faculty and staff.
Hi, my name is Nishay Chase. I'm a junior here. I major in public health on a bio track. One of my questions is that I myself take a lot of STEM courses, and so do you have any research or things about not just the mentors or the professors, but the actual male students that will be in that group as well, that sometimes seem more superior than the women that's even in the group itself?
I think having male students who are respectful and also having a male faculty member who sets the tone for the class is crucial. There's actually some research showing that when women students have male peers who are sort of respectful and who indicate that by their behavior, it increases these women's sense of belonging in engineering. I also think, so to the issue of setting norms, one thing that students can do themselves, male students and female students and also faculty, is if somebody interrupts a woman student, which I've heard lots of anecdotes about that, is to just say, wait a second, let her finish, and then we'll come back to it. Or if somebody's idea doesn't get traction, to amplify that idea and to say, so-and-so said the same thing, it went by really quickly, but I think her point was a really important one. So some of it is just training, socializing students, women and men alike, to be more sort of collaborative and respectful and not assume that some of them are better than others. And some of it is on faculty like myself and my colleagues here to explicitly set the norm, which I think does change the dynamics of the classroom or the lab and so on. Thank you for your question. Yes.
Hi, my name is Emma. I'm a senior bio major, and I actually read for a class your paper and a few commentaries on it. And one of the commentaries I read kind of talked about how if you focus on the minority in-group and how that mentoring in that specific group will improve, your willingness to go forward in that group. It also could possibly isolate further that group, that minority, and cause kind of an us versus them mentality. And I was just curious as to what your thoughts were on that.
Yeah, that's a good question. I actually remember that commentary. I think that for students who are really small numeric minorities in a major, in a field, they will always be interacting with students who are different from them on that identity dimension, right? In class, in labs, in study groups, and so on. So I think having a peer mentor or a small group who are like you doesn't negate or is not going to be more than all the other experiences a student has during her regular day, where she's in a much more mixed group. So I don't think it does the isolation. I think what it does is the inoculation. So that's sort of one point. The second thing is, again, I think there's a timing issue. I don't think this is as important for juniors and seniors. I think it's important for first-year students to have that few people that they can go to who are their buddies, and maybe they go to them and rely on them and have lunch with them once a week or once a month. Maybe they don't, but at least they're always there. So I think that that particular commentary was imagining that these women were only hanging out with other women, which is certainly not the case at a co-ed school. So I don't think it has a negative effect and creates an us versus them. I think rather it gives them an anchor and a way to just go outside of their comfort zone and be more confident in their classes in a way that otherwise they may not. So I've been to some of, I often go to some of these courses in physics or astronomy or engineering. It is remarkable. I mean, you see in a class of 100, 10 women scattered here and there. That feeling is quite isolating. So I think having something different matters.
Thank you.
Yes.
Hi, my name is Tori. I'm a senior geoscience major. I've noticed with my male and female faculty advisors that it's different. The general feeling and vibe that I get is different. My male mentors will speak to me as more of a colleague in a very professional way, and my female mentors will talk to me almost like they're my friend, and the same amount of work gets done and more happens, but I was wondering whether you could speak to that in a sort of relating to people on a professional level.
Yeah, that's a really good question. So in our peer mentoring study, we actually were interested in the content of the conversations between mentor and mentee. So these are not faculty, but they are senior male and female students paired with these first-year students. And we coded what they said, or the conversations based on was it more socio-emotional, kind of this being your friend? Was it more academic? What classes are you taking? How are things going? Talk to this professor or that TA, those kinds of things. Was it more career-oriented, what you're going to do next, or whose lab can you work in? It turned out, much to my surprise, there was no difference. That for all the mentors who were women and men, the mentees and the mentors were mostly talking about academic and professional stuff, not very much sort of personal or emotional stuff. So I don't know, at least from that study, I think what you're raising is whether with faculty and student advising, whether your experience is something more general or whether it is something that is specific to your relationship with those two people or those few people. The only thing that I can imagine there being difference in is more conversation about how to navigate. There's actually some research that shows that women advisors in science talk to their advisees more about how to navigate the system, which is not the science itself just, but also how do you work this essentially the sociology of science, how do you find your place, but not necessarily more emotional stuff. But I think you should tell your advisors what you need and what kind of advising is most useful for you, because there are big individual differences in what students want. Some students want to go directly into the academic stuff, but other students want a little bit of, I want you to tell me, or I'm having this concern, should I be worried about it? It really depends on the student. So I would say for all of you who are students in this group, be proactive in your advising relationship. Tell your advisors what you need from them. You're in some ways in the driver's seat, even though it may not feel that way.
Thank you.
Yes.
Hi, my name's Arlie. I'm a sophomore.
Yeah.
So my question is, in a lot of your research, I think you tried to take out any kind of difference in action. So it was just like whether they were the gender, female, male,
Yeah.
whatever, to show the difference. But I did notice on some of your graphs, there was a slightly difference between in the males, between who taught female or male, and there was better scores for the female professors for males as well. And so that made me wonder, because you talked about how the gender discrepancy and discrepancy in other things like racial, ethnic minorities are very similar. So can you speak to, do you think that having that experience of being isolated within the STEM field would help people be able to reach and teach other students of different minorities better?
Will feeling isolated in STEM fields for women allow them to teach students of color?
Yeah, or vice versa, where maybe a racial minority who is
Yeah.
male would be able to kind of connect to a female student better as well.
Yeah, I would think that. So I think that when you've experienced something yourself, it sometimes makes you more aware of how other students similarly situated, maybe from other identity groups, might feel. So yes, in some ways, I think that might be true. But in other ways, I think the experience of being a student of color in some ways can be quite different than being a woman. So I would say an answer that is not probably that satisfying. It depends. In some cases, if someone is from an identity group where they've had certain experiences that have been that makes them more sensitized to it for other groups. But I don't think it's always that way. I wish it were. I wish there were sort of more allies. I think it depends on the instructor or the faculty member or the boss, how much they are attuned to these kinds of issues.
Thank you.
Okay, so I think we are out of time and there's a hard stop, so I'm going to hand it off to Rick.
All right,
Thank you.
so thank you very much.